March 2020, paper 2, variant 2. Question 1, what is the area of the metal sheet? Length times width. The length would be from 10 to 45, which is 35 centimeters, and the width would be from 5 all the way to 25, which is 20. So 25 times 20 is 700 centimeters squared. As the ball falls, the air resistance increases. Which statement is correct? As the air resistance increases, what happens to the acceleration? The acceleration decreases. The resultant force decreases and the acceleration decreases until it reaches a constant speed, terminal velocity. A compressed spring projects a ball horizontally in a vacuum chamber. On Earth, the ball reaches the chamber floor 4 meters in front of the spring. An identical experiment is done on the moon. The gravitational field strength is lower on the moon than on Earth. The experiment results on the moon are compared with those on the Earth. Which statement is correct? Okay, so he's comparing the speed and the distance traveled, right? The horizontal speed is greater on the moon, or is it the same on the moon? If we think about it, force equals ma, force equals mass times the acceleration. So the horizontal speed has to do with the force due to this compression, which is the same, right? The force due to the compression will be the same. This is not a vertical force, or this is not the force due to gravity or nothing. This is the force due to the mass of this ball, right? Due to the mass of the ball. So if the mass of the ball hasn't changed, therefore the force would not change and the acceleration will be the same. So if we're talking about the horizontal speed, then the horizontal speed will be the same. Again, the horizontal speed will be the same. But the vertical speed will differ. Yes, the vertical speed might differ, and therefore this would affect the distance which would be traveled vertically or whatever. Okay, so for example, he's saying that the ball hits the floor 4 meters in front of the spring, or the ball hits the floor more than 4 meters in front of the spring. So you have the spring, okay, this is the spring and this is the ball. So the ball is launched this way. On the moon, the gravitational effect on the ball will be less, and therefore the ball will take a longer distance to fall, right? To take a longer time, longer distance. So instead of 4 meters, no, actually it will be longer than 4 meters on the moon. Okay. Diagram 1 shows a piece of flexible material. What happens to mass and what happens to the weight when you compress it? The mass doesn't change and the weight does not change as well. The volume can change, maybe the density would change, but the mass and the weight will not change. You have the strength of the gravitational field and the distance from the Earth. Which row describes the effect that this has on the mass and the weight of the object? Does the mass change? Does the mass change as you increase the distance? The mass does not change. No, you haven't removed any of the mass of this object, so the mass is unchanged. What about the weight? It decreases, yes. As you move further away, the weight decreases. A measuring cylinder contains 40 centimeters cubed of water. A solid metal ball is dropped into the water and the level rises to 56. The mass is 80 grams. What is the density? Mass over volume. Mass is 80 grams and the volume would be the difference, 56 minus 40, 80 over 16, 80 over 16, which is 5 grams per centimeters cubed. Car travels along a horizontal road at a constant speed. 3 horizontal forces act on the car. Two of them are shown. Where is the third horizontal force? Where is the third horizontal force? If the car is moving at a constant speed, then the forward forces should be equal to the backward forces. The driving force should be equal to the resistive forces. The driving force is 1,500, and the resistive forces should also be equal to 1,500. So you're missing a 1,200 Newton force in this direction due to friction or due to air resistance as well, whatever. So this is the answer. Why? Because the resultant force has to be equal to 0. You have a car in a bend. What is the direction of the resultant force? The direction of the resultant force should be towards the center of the rotation, should be perpendicular to this motion. Inside of the bend, yes, perpendicular and inside of the bend. An athlete with a mass of 70 kilograms trains by performing push-ups. The center of mass of the athlete is cm, okay, and he's carrying a load of cl. The mass of the load is 6 kilograms. What is the upward force exerted by his two arms? Okay, so this is a moment question. You have a pivot. Where is the pivot? That's a really important question. Where is the pivot? The pivot is at his feet. This is his pivot. Okay, this is the only point which does not rotate. All of his body rotates around this point. You have cm, his center of mass, which is 70 kilograms, but you need to find the weight. Can I just multiply by 10 to make life easier? Yes. So this would be 700 newtons. So cm, his center of mass, is 700 newtons in this direction. And then you have the load, which is 6 kilograms. Again, at this point, 6 kilograms, you can multiply it by 10. So 6 times 10 is 60 newtons. So now you have the 700 Newton force and the 60 Newton force causing an anti-clockwise moment. He needs to create a clockwise moment in this direction with a certain force, and you do have the distance. So basically, clockwise moments are equal to anti-clockwise moment. Force times the force applied by his arms times the distance to the pivot. What is the distance to the pivot? It's 1.3. Right? 0.1 plus 0.3 plus 0.9, this is 1.3. Anti-clockwise moment, you have 700 times 0.9 plus 60 times 1.2, right? 60 times 1.2. So what does this add up to? 700 times 0.9 plus 60 times 1.2. This is 702. 702. This is equal to force times 1.3. When you divide by 1.3, divided by 1.3, this is a force of 540 newtons. Again, if you used 9.8 instead of 10, it would have given you a really close answer. An air pistol fires a pellet forwards. What is the motion of the air pistol? If the pellet is moved forwards, then the air pistol has to move backwards, right? With a speed greater or less? With a speed definitely less, right? Because of its mass. They have the same momentum, but since it has a greater mass, so it has a smaller speed, which row describes an advantage and disadvantage of wind turbines. No fuel needed. Okay, harmful gases, no. Variable supply, this is a disadvantage actually. Advantage, no harmful gases released, okay, but the disadvantage is a variable supply, yes. An electric motor provides 900 joules of useful output energy. The efficiency is 60%. How much electrical energy is supplied to the motor? Okay, we want the input. You have the output and you need the input. So efficiency is equal to, efficiency equals to the useful output, okay, over the total input. Efficiency 60%, which is 0.6. You have the output, which is 900 over the input. We do not know the input, so 900 over 0.6. This is 1,500 joules. A crane takes 2 minutes to lift a 500 kilogram load to the top of the building that is 12 meters high. What is the useful output? So the power would be equal to the energy over time, or mgh, because this is the gravitation potential energy. mgh over the time. 500, again, times 10 because it's much easier. But again, in your actual exams, you should use 9.8. 500 times 10 times 12 divided by the time, which is 2 minutes, but you have to multiply it by 60. You have to multiply it by 60 to find it in seconds. Okay, so 2 times 60, 10 times 12, these will cancel out, so it's 500 watts. A skier is standing still on a flat area of snow. The weight of the skier is 550 newtons. The total area of his skis in contact with the ground is 0.15 meters squared. What is the pressure? So the pressure would be area, force over area. Okay, pressure equals force over area. 550 divided by the area, 0.015, giving you around 37,000. A tall cylinder is partially filled with two liquids which do not mix. You have position Q and position P, which graph shows how the liquid pressure varies between P and Q. Between P and Q. So as you move from P all the way to Q, what happens to the pressure? The pressure increases, right? Okay. Should it increase with the same rate as in C, for example? No, it shouldn't increase. Should be constant. No, it will increase, but not with the same rate. Why? Because you have two different liquids with two different densities. As you start in liquid P, for example, or in the first liquid from position P, is the pressure increase at a greater rate or at a lesser rate? Should the pressure increase be greater or should it be less? It should be less. Why? Due to the density. So the density of the first liquid is less, and the pressure increase, the rate of the pressure increase would be also less. Which means what? Which means that the slope, when you draw the slope, it would be at a lesser rate, right? And then as you move to the second, as you move into the second liquid, the pressure increase would be greater. The slope would increase. Okay. When pollen grains in water are viewed through a microscope, they are seen to be in continuous rapid random motion. This Brownian motion is due to what? Convection currents? No. Bombardment by a single molecule? No. Uneven? Yes. By water molecules on different sides. Yeah. This is the Brownian motion. Correct. Student measures the mass of warm water. Why does the mass of the water change? The mass keeps on decreasing. Why is this so? Due to the evaporation. Yes. Which points are fixed? This question is cancelled. Okay, so you have specific heat capacities of aluminum, iron, ethanol, and water are given. 1 kilogram of each metal is put into 5 kilograms of each liquid. The starting temperature of each metal is 60 degrees and the starting temperature of each liquid is 10 degrees Celsius. Which example has the highest final temperature? Which example has the highest final temperature? What do I mean by the highest final temperature? I do not want the metal to cool down that much, but I want the water, not the water, the liquid, to increase by a lot. Eventually, it will reach a temperature somewhere in the middle, right? But I want it to be as close to the 60 degrees Celsius as possible. You want this temperature to be as close to the 60 degrees as possible. So what should I do to the metal? I need the specific heat capacity of the metal to be as high as possible. I need to increase the specific heat capacity of the metal, and I need to decrease the specific heat capacity of the liquid so that it could lose so that it could gain energy quickly and so that the metal could lose energy as slowly as possible or as little as possible. Okay, again, you need to increase the specific heat capacity of the metal and you need to decrease the specific heat capacity of the liquid. So, for example, when I want to choose the metal, I would choose the aluminum. Why? Because it contains a lot of energy. They are at the same temperature, the iron and the aluminum, they are at the same temperature of 60 degrees Celsius. But the aluminum has a specific heat capacity of 900 joules per kilogram degree Celsius, which means that it contains a lot more energy. To be specific, it contains twice the amount of energy. It contains what? Twice the amount of energy as in the iron. Therefore, when it starts to lose energy, it would need to take, let's say, twice the amount of time, or you'd need a lot more energy to be lost from the aluminum to decrease the same amount of temperature, or whatever the temperature drop. You want the temperature drop to decrease as little as possible, and therefore you need to increase the specific heat capacity. What about the specific heat capacity of the liquid? You need to decrease it as possible. Why should you decrease it as possible? So that the temperature increase of this liquid would be as easy as possible. So it wouldn't use up as much energy from the aluminum, for example. It wouldn't use that much energy from the aluminum. It would use much less energy from the aluminum. Therefore, the final temperature of both of these materials together would be, let's say, 50 degrees Celsius. For example, I'm saying if you add aluminum and ethanol, the final temperature would be 50 degrees Celsius. What happens, for example, again, I'm just stating, for example, if you add aluminum and water, no, this would be much less than 50. Maybe it would be 40, right? Might be 40 degrees Celsius, and so on and so forth for the iron and water, for example. Okay, so you need to increase as I said, increase the metal and decrease the ethanol or the liquid. Metals are good thermal conductors. Insulators are poor thermal conductors. Which description of the mechanism of thermal conductivity is correct? An insulator's conduction takes place by electron transfer. No. Conduction takes place by electron transfer only. Metals, conduction takes place by electron transfer and molecular vibrations. Yes. A teacher shows his class a cup. The cup is made from thick plastic with lots of tiny air bubbles in it. He asks why the cup is so good at keeping a hot drink warm. It contains air, which is a poor thermal conductor. It does. The air is trapped, so very little convection is possible. Again, true. The plastic is poor thermal conductor. Yes, 100% true. A boy jumps into an indoor swimming pool. He notices that the water appears to get colder as he goes deeper. Which statement is correct? Cold water is more dense than warm water, so it sinks to the bottom of the pool. Yes, convection. Convection, right? Each student uses a different gap size and different wavelength. Which student produces the waves that has the most diffraction? How can you increase the diffraction? By decreasing the gap size and increasing the wavelength. So you'd say, I haven't increased the wavelength. There is a longer wavelength, for example, 2 and 2.1, which is true, right? It's not the longest wavelength. But comparatively, when you compare this wavelength to this gap, they're almost equal. They are almost equal. Therefore, this diffraction would increase. But when you compare this wavelength 2.1 to 3.0, no, it's less. 2 to 4.0, it's half of it. So this is wrong. You need to actually increase the wavelength compared to the gap size. Okay, compared to the gap size. You have some diagrams, some waves being produced, which are longitudinal waves. Sound waves, aren't they longitudinal? Yes, they are. These are transverse, and these are longitudinal waves. Sorry, they are longitudinal waves because they move to the left and to the right. So only 2 and 4. Which diagram shows how the light from the candle is reflected by the mirror? How the light is reflected by the mirror. So is, for example, whenever you have an object, the image of this object has to be on the other side, exactly, right? It has to be on the other side of this of the object. Okay, so A seems to be right because you have the angle of incidence and angle of reflection. They are the same. B is wrong because how is the ray reflected back on the normal? This is wrong. C is wrong. Why? Because the image of the candle should be in front of it. So this is wrong, and D is also wrong. The only correct answer would be A. A converging lens can be used as a magnifying glass. What will be the nature of the image? Virtual, upright, and enlarged. virtual because it's a magnifying glass. The water wave of blue light changes from 4.5 to 3.5 as it passes from air to water. What is the speed of this light in water? So initially it was 4.7 and finally it was 3.5 in water. Can I find the speed? Yes, I can find the speed. You can use two different equations, but for simplicity, let's use the longer way around by finding the frequency. Can I find the frequency? Yes, the frequency of this wave in air would be the speed of it in air over the wavelength in air. 3 times 10 to the power of 8 divided by 4.7 times 10 to the power of -7. So let's calculate it. 3 times 10 to the power of 8 divided by 4.7 times 10 to the -7, which is 6.38 times 10 to the power 14. 6.38 times 10 to the power of 14. Can I find the velocity in the water? Yes, I can find the velocity. It would be the frequency times the wavelength. You have the frequency which is unchanged times 10 to the power 14 times the wavelength, which is 3.5 times 10 to the -7. And the speed would definitely be less than 3 times 10 to the power of 8. So if you multiply by 3.5 times 10 to the power of -7, this would give you 2.2 times 10 to the power of 8. You have a rarefaction, you have compression. Okay, number of particles in the rarefaction and the number of particles in a compression. They decrease and they increase, right? So the quieter sound, let's see what's happening. If you have a quieter sound of the same frequency is made, quieter sound of the same frequency is made. What do I mean by a quieter sound? What do I mean by a quieter sound? The amplitude has decreased, right? The amplitude has decreased. So how does this affect the rarefaction and how does it affect the compression? If you have the same frequency, if you have the same frequency, so then you wouldn't change the frequency. As you decrease the, look again, as you decrease the amplitude, let me write it down, as the amplitude decreases, the compressions get less compressed and the rarefactions, okay, get less rarefacted. What do I mean by less compressed and less rarefacted? The compressions or the number of particles in a compression wouldn't be as compressed as the initial wave, and the number of particles in the rarefaction wouldn't be as much rarefacted as before. Therefore, the number of particles in the compression, they would get a little further apart, right? And in the rarefaction, they would get a little closer together. I'm talking very small changes, very slight changes. The compressions would be less compressed and the rarefactions would be less rarefacted. Therefore, the number of particles in a rarefaction would actually increase and the number of particles in a compression would decrease. This is why this is due to decreasing the amplitude. When you decrease the amplitude, this is what happens. If you increase the amplitude, another question, if you increase the amplitude, the compression would get more compressed and the rarefaction would get more rarefacted. This might be a difficult question, a little bit difficult, but again, this is how you should think about the solution for this question. Okay? Diagrams show three different metals, P, Q, and R. Diagram 1 shows situation when there is a current. Okay. Diagram 2 shows situation when there is no current. Which rows correctly identify the metals? So P wasn't affected at all, right? P did not attract the nails at all. Q attracted them when there was a current and then it did not when there was no current. R attracted them and then it kept on attracting them. This means that R is a permanent magnet, right? R is steel. Q is iron. Why? Because it attracted and then it did not. And P is a non-magnetic material. So P is copper. Q is iron, R is steel. Okay? Now, question 30. Which row describes conventional current and the electron flow? The conventional current passes from the negative to the or from the positive. So it goes from the positive to the negative. From the positive to the negative, while the electron flow moves from the negative to the positive. So it is C. Student makes four resistors using different wires. The wires have different diameters. Which piece of wire will make the largest resistance? Decrease the diameter and increase the length. Student wants to determine the resistance. Which circuit should be used? You have the ammeter in series and the voltmeter in parallel. Ammeter M1 reads 1 amps. What are the readings on M2 and M3? This is a series circuit, so they all have to give the same reading of 1 amperes. What is the current in the cell? Current in the cell would be adding both currents. What is the current in this resistor? So if you have a 4 ohm resistor and a current of 1 amperes, then the 2 ohm resistor would have a current of 2 amps. Why? Because as you decrease the resistance, the current increases. As you decrease the resistance, what happens to the current? The current increases, right? So when the current increases, you'd say, well, it would be doubled. Since this is half, so this would be doubled, 2 amps, and then the total current would be 3 amps. You can use it, you can find the current using another equation, which is by finding the voltage of the second resistor. You can find the potential difference, and then you can find the total resistance, and you can find the total current using the total resistance and the voltage. You can do that. Okay, V equals IR, so you'd have the voltage 5 volts, and then you can find the and find the resistance. But again, it's a slightly longer a slightly longer way of doing that. 35 is cancelled. 36. How many turns are in the secondary coil? Can I find the number of turns on the secondary coil? Yes, you have 240, 1000, output voltage of 12. Can I find? Yes, so 1000 times 12 divided by 240. What's 1000 times 12 divided by 240? This would be, yes, 50. Yes, 50. Which particle experiences a magnetic force acting out of the plane? Okay, out of the plane. A and B are cancelled. A not cancelled. They are wrong. Why are they wrong? Because they are moving parallel to the magnetic field, right? They are moving parallel to the magnetic field. So, for example, let's try out C. Using Fleming's left-hand rule, you'd have the magnetic field to the left, the force or the particle moving downwards. You'd have your second finger pointing downwards, and the thumb would be pointing out of the page. Is the thumb pointing out of the page? Yes, this is correct. This is what we actually want. In D, you'd use the Fleming's right-hand rule, the first finger pointing to the right and the second finger pointing downwards. You'd have the thumb pointing into the paper, which is wrong. Okay, this is wrong. So it's C. Question 38. When Rutherford bombarded thin gold foil with alpha particles, he found that some alpha particles were deflected through large angles. Which statement explains this deflection? Most of the atom consists of empty space. He did find out that most of the atom consists of empty space. But was this the conclusion of finding that some of the alpha particles were deflected through large angles? No, it was not. This was not the conclusion. All of the positive charge and most of the mass of the gold atom are concentrated in a small volume. Yes, this is correct. Because the charge repelled, this positive charge repelled the alpha particles, which are also positively charged. So due to this repulsion, the alpha particles were deflected at large angles. Okay, it's not spread out evenly, and it's the negative charge is not concentrated in the center. 39. A diagram shows the path followed by alpha particles. What happens when beta particles passing through the same electric field? So alpha particles are moving downwards, beta particles will move upwards. That's easy. It's not that hard at all. The graph shows the count rate from a radioactive source over a period of time. What is the half-life of the source? So starting off with 2000, you divide by 2, 1000. So the half-life would be 1 hour.